Okay, so this one I had a go. I didn't read the question carefully, and look, I made a mistake. I then went down to see what the Valentine's Disco was all about, and now I'm back up here. So if you can hear music in the background, that's the Valentine's Disco on the go. So this one is just a way of thinking, really. So there's an equilateral triangle, and the sides are 8 each, so that's that. So the perimeter of this shape is actually 24, and it says a square has the same perimeter. So here's a square, and these sides are all the same. So you have to think of a number that can go here, here, and here. That'll make 24. So basically you can divide 24 by 4. So each side is 6. And to find the area, it's just the length times the length times width or whatever. So the area is going to be 6 times 6. So it equals 36. Now, because it's in centimetres, you've got to be really careful. Centimetres squared. Because it didn't include it here. By putting it, I'm probably going to get... So this one's really an interesting question. Quite difficult, I think. I think it's as difficult as some of the higher questions that I've seen on the other videos I've done for the high students. So she's organising games for children in a class. She's going to put the children into teams. If she puts them in a team of 4, there's 2 left out. She puts them in 5, there's 3 left out. So we have to work out the smallest possible number of children she's got in her class. So if I had a normal question like this, what we do, we'd be looking for a common number. So we do the 4s and the 5s normally, and we'd look for a number where they're going to be the same. But this time it's a bit weird, really. It's slightly awkward. So normally we'd have 4s, so we'd have 4, 8, 12, 16, 20, and so on. But this is saying if we do it like that, there's always 2 children left out. So we have to actually add 2 to these. Like that, okay? And then we do the 5 times tables, 5, 10, 15, 20, and so on. But if you do it in 5s, there's always 3 children left out. So if I add 3 to all these, you can see I've got 8, 13, 18, 23. The smallest number that shows up first like this is 18. And that's a really unusual question, and we've not seen one like that before. So it's really unique, where we will make some more of these ones up for you to practice. Okay, right, to really have to think about my approach for that one, hence why I got another bit of paper, because I had to do it again. So me being really confident at the beginning, I've really got to read the questions carefully. Right, this one. So expand and simplify. So see a bracket, expand. So 7a stays the same. 4 times a is 4a. 4 times 2b is 8b. So I've got that. And I've got 11a minus 8b. Because the a's go together to make one lot of a. So 11a minus 8b. Okay. Right, multiplying. The n stays as an n. And the law of indices, if you multiply, you add. So you add the 5 and the 6 together to get 11. Factorise is the reverse of what I did here. Here I expanded the bracket. Factorise, I'm going to put it back into brackets. I've got to think about what's common. And you've got to basically think on these ones, which times table can you see? So I can see the 5 times table. So 5 is going to go on the outside. And if I take 5 out of 5x, I've got x. If I take 5 out of 10, if I divide by it, or count how many 5s go into 10, it's 2. So that's 5x plus 2. Okay. A supermarket car park has 200 spaces. 10% of the spaces are for staff. So I'm just going to do that now. So 10% of the spaces are for staff. So 20 spaces are for staff. Okay, so I'm going to get bits and bobs of credit for different parts of the calculation. And if you struggle to get full marks on questions like this, you have to really take your time to work bits out. So 10% is 20 there, you can see that there. Okay, the other spaces are for disabled people, for parents and other customers, and that's the ratio of those people. So this will be disabled people, parents and other customers. Paul is going to paint a sign for each of the spaces for staff, for disabled people and for parents. He's not going to paint the signs for spaces for customers. Work out the total number of spaces Paul is going to paint for a sign for. So 20 people are the other people. Okay, right, 20 people. He's not going to do it for other customers. He's not going to, right. Okay, so we're going to have 20 spaces for the staff, they're going to have it painted. So you've got 20 there. We need to find how many people are the other customers. Okay, so that's what we need to find, the other customers. So we know so far that 20 staff are there, so that leaves 180. We know the ratio for the other groups is this. Okay, so what we're going to do is we have to find out what one part of this ratio is worth. Sorry, that was off the screen there. We have to find out what one part of each ratio is worth. So how much is that one worth? There's 2 lots of them there, there's 7 lots there. So what we do is we first add them together. So you add the ratio together to get 10. So there are 10 parts to the ratio. And if I do 180 divided by 10, I know that each part is worth 18. And so what I do now is I've got one part there, so I'm going to multiply that by 18, so that's 18. Multiply that by 18, so that's 36. And I could multiply this one by 18, but it doesn't, they're not going to do signs for other customers, and that is third in the question, and that's the third number on the ratio, so that is actually the number for other customers. So I don't have to do 7 times 18, but I could. So we have signs for the staff, so we've got 20 at the beginning. We got signs for the disabled people, which is actually 18 from here, so I'm going to add 18. Okay, and then we have got 36 there for, who was that? For the parents. Okay, so we need to add those together. So 20 at 18 is 38, 38 at 36, so I'm just going to do that like that if I'm in doubt. So that's going to be 14, carry 1, that's going to be 7, so it's 74 signs that they're going to paint. So it's a really good question because you have to do percentages, basic percentage. So I knew that 20 people would be staff. I had to take that off the 200 I had and then do a ratio question where you add the ratios together and divide to find how much one part is worth. And then I've multiplied the ratio again. I picked out the right ones because I had to read the question to show that it was disabled for the ratio of 1, parents for the ratio of 2, and I used those 2 here. And then it meant that I'd have to know that I'd have to add together. So it's really a difficult question if you're not too sure of the ratio, but it's really good practice. Okay, it's a good one to have. Right, 22. This is a nice, straightforward question. Translation is the easy transformation, and what it means is it just moves left, right, up or down. If you draw that on first, this is a good guide. So the top number is left and right, and it's a minus, so it's going to go left 3. So let me just do that. So move this 1, 2, 3. Just check your scales going in ones, because if it doesn't go in ones, this is not going to work out very well. And the bottom one is -1, so that means down 1. So that moves down 1. And if I construct that now, you can see that's where it's going to go. People use tracing paper and move it, but I do like to just move one corner and draw it from there. But tracing paper would work. Right, this one, describe fully the transformation of maths B to C. The higher paper, this is a bit dodgy because it didn't put the question in correctly, but this one is really good practice. It's changed direction, so it's definitely a rotation. I also know that because it's 3 marks, reflection's only worth 2 marks, translation's only worth 1 mark. It's not getting any bigger, so it's not an enlargement, so it only needs rotation. And if I look at the shape, what is it? B to C, so it's going from there to there. Okay, now, doesn't matter which way you go. I'm going to go this way, 90 degrees. You can go 270 the other way, but that, if I go that way, is anti-clockwise, so you've got to say that. Okay, so it's rotation, angle, direction, and the last one is the centre of rotation. The last one's a little bit harder, so you have to follow this little routine. So what you've got to do is find a point where, when I spin these around, this will go straight onto there. So let's just go sort of midway. So I'm going 0, 1. And when I spin it around 90 degrees, you can see I've missed it. So that didn't work. So go back to the beginning and don't use that coordinate again. So now I'm going to go bang in the middle. Again, it's not worked. I'm going in the wrong direction. Okay, so I'm going to go down. Right, hit it. Can you see? It's going from there and it's on now. and that's me putting my pen at 0, 0. So that is working. So that's the centre of rotation, 0, 0. Okay, so easy to recognise, easy to say what it is. The angle is pretty easy, direction is, but the centre of rotation is a little bit trickier. Okay, so it needs to be practised. Right, this one. Make H the subject. So in the end, it will say H equals. Okay, that's the whole point. So draw a line. We're going to unpick this. So we've got 3 to sort out. We want to get rid of the 3, and we want to get rid of that -5. So to eliminate the -5, we're going to add 5. Okay, and that is going to be G add 5 equals 3H. Now it's just like solving an equation, but this time I haven't just got a value here. I've got a letter, so it can't combine with it. You just write add on the end. Effectively, it was on the right as a minus, and now it's on the left as a plus. Now I'm going to divide by 3 because I want that 3 to go, because H is not by itself. Okay, when it goes, that leaves H, so that's what I was after. H is by itself. And then all you do to divide by a number is draw a big line and put it underneath, because that says G plus 5 all divided by 3. So I can say H equals G plus 5 all divided by 3, and it doesn't matter that I've switched it round. That's absolutely fine. Okay, so that's a nice easy one if you're happy with solving equations. It's just a little step further to go into rearrangement. Okay, Tina is going from London to the French town of Lille. Tina will drive from London to Dover. She'll go from a ferry from Dover to Calais, and then she'll drive from Calais to Lille. The distance from London is 18 miles. The distance from Calais to Lille is 120 kilometres, so they're not in the right format because we deal in miles and in Europe deal in kilometres. It does tell us how many miles are in a certain amount of kilometres, so 5 miles is 8 kilometres. She's got enough fuel to drive 150 miles, so we need everything in miles. And we need to figure out if she's got enough fuel. So we need to turn this 120 kilometres into miles. Okay, we know 5 miles equals 8 kilometres, but we actually want to know what 120 kilometres would be. So we need to figure out how 8 has turned into 120. And then once I've figured out that number, I can multiply this side by it as well. Okay, so if you're not sure how you do this, if you're trying to figure out what something's been multiplied to make something else, if you divide instead, it'll tell you what it is. So how many 8s go into a 1? 0, carry 1. How many 8s go into 12? That's not a very good one there, but you can see that. How many 8s go into 12? 1, remainder 4. And how many 8s go into 40 is 5. So this has been multiplied by 15. So I need to multiply this side by 15. Okay, so 5 times 15. 5 times 5 is 25, carry 2. 5 times 1 is 5, add that is 7, so that's 75 miles. So this 120 kilometres is actually 75 miles. She went from London to Dover at 80 miles. She has done 75, she needs to do 75 miles for Calais to Lille, and that gives us 155 miles. She can only drive for 150, so she doesn't have enough fuel. Okay. That one was on the higher paper. That definitely was on the higher paper. Okay, let's have a look. ABC, just follow your fingers. ABC, this is triangle here, the big one, is an isosceles triangle. ABD. ABD is also an isosceles triangle. Work out why. You must give reasons, so there's more than one reason for your answer. So, ABC, this full thing, is isosceles, so this angle here is the same as 68. The base angles on an isosceles triangle are equal. So I can say that all of that is 68. If all that's 68, I then can use that to find this top angle here, because there are 180 degrees in a triangle. If you just think about the big triangle, ignore this line in the middle, I've got this on the go, I've got 68 there, 68 there. So this one is going to be 180, take away the two 68s. So if I just add 68 together, 68, I get 16, carry 1, that's 12, so it's 136. So I'm going to take that away. Take away 130 would be 50, so take away 60 is 44. So this one is 44, okay, angle BAD. BAD is 44, okay, and I've explained why. It did say that this triangle here, ABD, is also isosceles, okay, and that means that this angle here and this angle here that I've shaded in, not the full thing, not 68, are the same. And I've already repeated that isosceles triangles have the base angle the same. So angle, what is it, ABD is also 44. Okay. Now I've got a different triangle where it's sort of on its side like this, where this one is 44 and this one is 44. And I've already explained that there are 180 degrees in the triangle. So if I add the two 44s together, I get 88. If I take that away from 180, I'll get this angle here, which is here on my diagram, which is right here. That's what I'm calculating now. So if I take away 80, that'll be 100. If I take away another 8, it'll be 92. So that's that there, that's 92. And now, these are on a straight line. This diagram here, you can see these on a straight line. So there are 180 degrees on a straight line. So 180 take away 92 will equal y. So it's the same calculation. It's going to be the same as 88. So if you take away 90, it's 90. Take away number 2, it's 88. So y equals, did it really pull out? Y equals 88 degrees. And we explained everything that we did there. So it revolved around the base angles being the same on an isosceles triangle. We used 180 degrees in the triangle, and we used angles on a straight line. And they're the key facts that you have to be able to write down to get everything that you need. The working out is half the marks. These highlight bits are the other half. Okay. Bisectors relies on you having this piece of equipment. If you haven't got this piece of equipment when you're watching the video at home or whatever, you just need to draw the arcs in and just understand the process from it. So you have to open the compass and pencil so it's over halfway like that, and then do a big arc across from one side, put your compass point on the other side like that, and go the other way. What that'll do is it'll give you this perpendicular bisector, and all that means is that you're going to have a line going through this line in the middle at 90 degrees. So it's going to be a perfect cross like that, and that's that one done. Okay, nice and straightforward. This one here was on the higher paper, so was this one. If we're into the higher paper now, I've explained before, and it's just testing your understanding in a different way. So Stephen's weight is 2x plus 9, Kevin's weight is 4x minus 7. Write down an expression in terms of x for the mean weights. So when you find the mean, you add something together and you divide by how many's there. So this has got 2 people, so I need to add these 2 together and then divide by 2. That's the mean. Okay, so I'm going to add these 2 together. So 2x plus 9 add 4x minus 7 equals 6x plus 2. Okay, I've got that and that makes 6x, and 9 take away 7 is 2. And then I'm going to halve them now. So half of 6x is 3x, half of 2 is 1. So it's an unusual question, and you probably haven't done a great deal of that, but in the end it's not too bad. Okay, it's quite straightforward. Okay. So an unusual one, and there'll be very little questions like that around to help you understand that. Okay, so we'll just have to generate some for you. Okay, right. This one is very similar to the question that we've just done. It relies on all sorts of things really to use. It's especially concentrating on isosceles triangles, so I'm going to be writing the same fact. This probably will not happen in a real exam. Let's have a look then. So BCD, so BCD and ABD are isosceles triangles. So these two are the same as each other. And if you look at it carefully, these two are the same as each other. So I'll colour these in. So these two should be the same as each other. Okay. AD is parallel to BC. So when you've got parallel lines, you could be using alternate angles, corresponding angles, complementary angles, co-interior angles, supplementary angles. It just depends which ones you use. Work out the value of y. So straight away, I know that isosceles triangles, the base angles are equal. So I'm going to do 180 take away 120, which is 60. And that's going to be shared between these two here. So if I do halve them, I know that that's 30 and that's 30. Okay. Now I've got no information to use. I can't go any further. There are a few ways to it, but the simplest way is to recognize that this line here is cutting through or connecting these two parallel lines, and if it does, I can draw this shape. Okay, so this, people call it the Z angle, but it's called the alternate angle. There, it's the alternate angles are equal. So alternate angles are equal. There's another way to do it, which is using interior angles, and knowing that all this is actually worth 60, but I'm not doing that one. So alternate angles are equal. So this angle here is also 30. Okay, now I've got this isosceles triangle here with these two base angles being the same, and I've already got 30 there. So what I'm going to do is a very, very similar process to the last one. I've got 180 take away 30, give me 150. And then I'm going to do 150 divided by 2, which means that this angle here and here are both going to be 75. Okay, and that's it done.